thank you very much for the invitation to come and speak to you today. I think it's just wonderful to see such a full room of eager faces. So what I'm going to talk about is I'm going to tell you a little bit about my own career, which is because it's just slightly unusual. And then I'm going to tell you a bit about really the history of women in mathematics and the sorts of struggles and things that they had to face and overcome in order to succeed in mathematics. And hopefully we'll kind of appreciate that things aren't quite where we want them to be now, but they were an awful lot worse in the past. So for myself, I came from a rather Victorian family that didn't believe in education for girls. I always say that my school, which shall remain nameless, would probably have done well in the league tables had there been league tables and table manners, but not a lot else. So they didn't sort of agree with the idea of going to university or anything like that. So I ended up spending some time working in an art gallery in Bond Street. Which actually was an amazing experience for all sorts of reasons, but I didn't really feel kind of completely satisfied, and I thought I really still want to go to university, and I thought I would do a degree in history of art, but I thought I was too old. I was in my mid-20s then, and mature students weren't really part of the landscape, and so I thought, oh, the Open University was just really getting going, and I thought that's what I'll do. I'll do it through the Open University. So I started doing history of art, well, art sort of courses, but at that time, with the Open University, you had to do 2 foundation courses, and I thought, well, you know what, I did like maths at school. Maybe, I of course thought that maybe I'd done all the maths there was to do, but maybe there was a little bit more, so I thought, well, I'll do the foundation course in maths, and I just absolutely loved it. To kind of cut a long story short, I wrote to King's College in London and said, you know, I'd really love to come and do a full-time maths degree, thinking they would say, well, I think carry on with the OU, you know, you're a bit old for this now. But I was really lucky. The admissions tutor thought it was kind of quite an interesting idea. And so I ended up going to do my undergraduate degree at King's, and I fell in love with the history of maths while I was doing my undergraduate degree. For various things happened. I was curious about the names, and any of you who've done an undergraduate degree in maths maybe have come across the Bolzano-Weierstrass theorem, and I thought, Bolzano-Weierstrass, well, that's kind of an interesting name. It's a bit better than Barrow Green. And of course I had no idea that Bolzano and Weierstrass were 2 completely different people. You know, I mean, people didn't sort of think to tell us much about that. And then the real kind of light bulb moment came when in a calculus tutorial, we had the person who was giving it started it off by saying, well, Isaac Newton, and I perhaps should say this in rather hushed tones in the Royal Society, as Newton was president of the Royal Society, but anyway, Isaac Newton, and so we were all sitting there, you know, Isaac Newton, calculus, and then he just said, second nastiest person to come out of Grantham. And of course, for those of you who have slightly longer memories, this was Maggie Thatcher time. And I mean, I had never thought about Newton as being nice or nasty. And actually, it makes a difference. Like in anything, of course, why shouldn't mathematicians be nice or nasty like anybody else? But of course, most people, when they learn mathematics, they don't learn about the people behind the mathematics. They don't learn about the fact that actually the human side of mathematics is important, and actually directs often the kinds of maths that we study or get studied and so on and so forth. Anyway, so I thought that's what I'm going to do. I'm going to do a PhD in history of maths, but I also thought I need to shore up the finances. So I worked in the city for a couple of years, thinking, well, I could get seduced by that, but I absolutely wasn't. Then did an MSc in mathematical physics because I wanted to get a bit more maths, because I by then knew I wanted to study the history of 19th century maths. And then I went to the Open University to do my PhD as a full-time student, because at that time it was the only place you could do a history of maths degree and be based in a maths department. And I knew that the kind of maths I wanted to study, the history of, was quite tough. And I thought, if I'm in a history department, I'm never going to convince the mathematicians that I'm serious. Whereas if I'm in the maths department, after my 8 years in the art gallery, I thought I can blag it with the historians. And actually, I was right. And then I got a postdoc at the OU and carried on and somehow managed to convince them to kind of permanently employ me. And I just have to say, I'm absolutely thrilled that one of my fellow PhD students at the OU, Michaela, is here today. So that was a real treat. I wasn't expecting to see her, so that's a special, makes the day even more special for me. So that's how I've ended up. And I think one of the things about the story is actually I just discovered I had a passion for history of maths. And that's what I would say, when I do give talks in schools and things, and I say, actually one of the things is, if you have a passion, then you'll enjoy it and go for it. So passion and persistence are my kind of watchwords, really. And I think are also watchwords of some of these women that I'm going to be talking about now. So without further ado, so I'm just going to be talking about the more modern period. I mentioned Maria Agnesi. Some of you may have heard of her. She's the first woman really in who's kind of that we know about in modern, as I say, in the modern period, 18th century. She is sort of described as the first female professor in maths. She was actually appointed to a chair in Bologna, but she never took it up. She never even actually went to Bologna. But she wrote a calculus textbook, and she was, by all accounts, an incredibly talented woman. She wrote this calculus textbook, which got translated from Italian into English, but she didn't make a career after doing that. She actually went into sort of charitable works. But I mean, I think she's a sort of a starting point, if you like. And she was really acknowledged and recognized in her time for her talent in mathematics. But having kind of studied and produced this textbook, she doesn't go on to do any more. But so I want to really sort of move on into the sort of 18th, 19th century. And on this slide, one of the things I think should be really apparent when you look at all of these women together, some of them you may have heard of, Emily de Châtelet possibly, Ada Lovelace, I suspect everyone's heard of Ada Lovelace, and a lot of you will have heard of Mary Somerville, for whom Somerville College is named, and I'm going to say a bit more about them. Elizabeth Ferrand, I rather doubt if any of you have heard of her. And she's there because, I don't know if you can see, but she has her portrait painted, and she's got a book behind her. And actually that book is Newton's Principia. And so, I mean, this is quite a remarkable painting, I think, to see a woman in the 18th century choosing to have her portrait painted with the kind of icon of Newton's Principia. And what it tells us is that at this period, and particularly, as I say, if you look at all of these women, they're all actually rather well dressed. They clearly come from a particular element of society. And particularly if we think of France in the 18th century, so Emily de Châtelet is the same kind of period as Elizabeth Ferrand. So there were women who were discussing mathematics within the kind of salons. I think, in fact, Elizabeth Ferrand had a salon. Voltaire came to it, Clairaut came to it, and so on. So they were discussing mathematics. But it's a very different thing to be able to be in this sort of polite society and discussing mathematics, to being a mathematician per se, and having some official role in the society that kind of singles you out as a mathematician. And this is absolutely what none of these women had. So I'm going to tell you a little bit. So that's all I'm going to say about Elizabeth Ferrand, but I want to now move on to Emily de Châtelet. Emily de Châtelet, it was well known, she consorted with Voltaire. She was, and they did science together and mathematics together and so on. And Voltaire writes his book about Newton's work. So it's not a brilliant exposition of Newton, but it's not bad. If we look in the frontispieces of it, we see a picture of Voltaire, and we see this other rather curious picture. And what could this be? In fact, what we see here is Newton up in the clouds, and then we see Emily de Châtelet with a mirror, and the mirror is reflecting Newton's ideas through her to Voltaire. And that's exactly what happened. it was through Émilie du Châtelet that Voltaire was able to write his work on Newton. But it's Voltaire's book. Her name isn't as one of the authors. Now, of course, at this period, people didn't tend to write books jointly in the way they do today, so one should remember that. But he does acknowledge her, but he acknowledges her like this. So we see to Madame la Marquise de, and he doesn't give her full name. Of course, everybody would have known who it was, but somehow it was still not appropriate to give her full name. But what's more important about du Châtelet is that she herself wrote a translation of Newton's Principia. And her translation of Newton's Principia is still the translation that's used in France today. And what's more, it contained a lot of notes, and it showed that she really, really understood it. And you should also know that Newton's Principia is desperately hard. I mean, it's a really, really tough book, and it was really recognised as such. So at the time, the fact that she really understood it, and there's complete evidence that she understood it, is full credit to what a strong mathematician she was. In fact, she died in childbirth shortly after she finished it, and it wasn't published until 10 years after she died, and it was published to coincide with the return of Halley's Comet. But she was a facilitator for Voltaire in his work, and then she created work of her own. So I'm not sure, I seem to be missing some slides here. So Mary Somerville. Mary Somerville, she also worked on Newton because her work, she wrote a book which was actually a translation to a certain extent of the work of Laplace. And now Laplace's Mécanique Céleste was the next stage from Newton's Principia. Newton wrote basically his work in geometrical terms. The Principia is basically a book in geometry, and which also is what makes it hard. Laplace is the one who brings the calculus, even though Newton was the person who helped introduce the calculus. It's Laplace who brings the calculus into into Newton's ideas, publishes his Mécanique Céleste, which is again fiercely difficult, no diagrams, really hard. And it's Mary Somerville who is the person who translates part of it into English, makes it accessible. And she is, again, she's accepted, she's known within society as being a strong mathematician, a strong scientist. She's the first person to publish in the Royal Society. She's the first person and only woman, rather, to have her bust placed in the Royal Society. But she could not be a fellow of the Royal Society. It wasn't even contemplated. Her husband was a fellow of the Royal Society, which is how her work was read in the Royal Society. And in fact, it wasn't until the beginning of the 20th century that a woman was actually put up for fellowship. Hertha Ayrton was put up for fellowship at, I think it was 1902, 3, 4, something like that. And she was turned down because she was a married woman, and as such she had no status, she had no legal status, so they didn't have to kind of think about admitting her as a fellow. And women could not become fellows of the Royal Society until the first women were 1945. And the first women mathematicians, Mary Cartwright, in 1947. It's not that long ago. I'd like to draw attention to the fact that Mary Somerville now is on the £10 note in Scotland. And this is my PhD student, Bridget Stenhouse, who is doing a PhD on Mary Somerville's mathematics, because people have looked at her much more generally as a scientist, but they have shied away from her mathematics. So Bridget has, and there are unpublished manuscripts in Somerville College, which Bridget is working on. She's also been on the Antiques road trip, talking about Mary Somerville. So, so she's really doing a lot of good work in bringing Mary Somerville's actual mathematics to the fore, where I think there has been a tendency where people have looked at women scientists, people interested in science in the 19th century and 18th century and whatever, and not to explore very deeply actually exactly what it is these women did and how they got their knowledge and how their knowledge was circulated and so on. And Bridget's doing really good work on Mary Somerville in that respect. Sophie Germain. Now, Sophie Germain is slightly different from those other women in that she doesn't come from that sort of minor aristocracy, sort of upper middle class. I mean, comes from a well-to-do family in Paris, and she learns her mathematics through, basically she's self-taught. And she thinks she wants to learn more mathematics. And this is a period when the École Polytechnique has just been established by Napoleon in Paris, end of the 18th century. And she wants to study. But there's absolutely no possibility as a woman that she can study there. So what she does is she adopts a male pseudonym and she writes to Lagrange, who's one of the people who's lecturing there, and engages him in a mathematical dialogue by letter. And Lagrange is impressed by this Monsieur Leblanc he's having his correspondence with and wants to meet him. And then when he meets him, finds that him's her. Actually, to Lagrange's credit, is not remotely put off by that and helps to encourage her. But the fact that she had to actually pretend to be a man in order to make progress. And she's the first, really one of the first mathematicians to make serious progress with a general approach to proving Fermat's last theorem. And she later won an Academy Prize. But one of the, this is also a letter from Gauss. Now, most of you will probably know, if you ask any mathematician, who are the kind of, you've got to give me your 5 greatest mathematicians, Gauss will almost invariably turn up as one of them. I mean, he's one of the absolute giants of mathematics of the 19th century. And she engages in correspondence with him. And he, again, like Lagrange, discovers she's a woman, and he's not put off by it. And I think this letter is really quite interesting. I mean, he says, how can he describe his astonishment and admiration, this esteemed correspondent metamorphosed into this celebrated person, yielding a paper so brilliant it's hard to believe. And this is the taste for abstract sciences in general, above all for the mysteries of numbers. This is number theory. It's very rare. This is not surprising, since the charms of this sublime science in all their beauty reveal themselves only to those who have the courage to fathom them. But when a woman, because of her sex, our customs and prejudices, encounters infinitely more obstacles than men in familiarizing herself with their knotty problem, yet overcomes these fetters and penetrates that which is most hidden, she doubtless has the most noble courage, extraordinary talent, and superior genius. So this is praise indeed. I mean, this Gauss is, as I say, absolutely one of the giants of mathematics at the period. So this gives us a really clear indication of Sophie Germain's talents, and that she was indeed able to make progress with Fermat's last theorem. And as some of you will know, I mean, when Fermat's last theorem was finally proved in the 1990s, there was a huge amount of publicity for it, because it had been remained intractable for so long. And it was the fact, you know, that Fermat had put in the margin of his notebook that he had got a proof of this theorem, the fact that if you have, as I put on the first slide here, this equation x to the n plus y to the n equals z to the n has no integer solutions for n greater than 2. We know the Pythagorean theorem, it's true, of course, but any integers greater than 2, there aren't any solutions. And Fermat said, you know, I've got a proof, but I can't put it in the margin. And so lots and lots of mathematicians had tried, and Andrew Wiles finally proves it. And so big hurrah, and fantastic television program about it, if you've ever seen it. But what about Sophie Germain? So this is the interesting thing, I think, is that her contribution had been just sort of subsumed by, and particularly there was a French mathematician called Legendre, And he made a bit of progress on Fermat's last theorem. And the work that Sophie Germain did got gradually, as kind of time went on, her name got kind of lost. And her work was sort of subsumed under his, because I think they just couldn't believe really a woman could have done what she did. And it was only then, with all this sort of excitement and things about the proof of Fermat's last theorem, historians started burrowing around in the archives in the Bibliothèque Nationale in Paris, and they found her manuscripts. And they could see precisely what she had done. And indeed, she really had made important progress. And so for me, this is really quite an important example of showing how, that a woman can be recognized by Lagrange and by Gauss, two of the really leading mathematicians of the time, and yet the people that come after she just gets kind of, she just gets faded out of the picture. And I'm happy to say she has now been restored to her rightful place in the mathematical pantheon. One of my favorite women mathematicians is Sofia Kovalevskaya. And I really like Kovalevskaya because she's somebody she has various lives, a little bit like me, that's about as much as I can say, but she had a kind of literary side to her life. She also was very keen on sort of emancipation of women and so on. And she was born in Moscow in 1850, and she got interested in mathematics, and she tells the story of how when her family moved to again, they were sort of minor aristocracy, they moved house, and they ran out of wallpaper, so her father wallpapered her bedroom with the text of his old mathematics textbook, and she used to lie in bed and look at these funny integral signs and various things and wonder what they all meant, and that's how she said she got interested in maths. And she wanted to study further maths. With a bit of reluctance, her parents had let her kind of study up to the age of sort of 17, but she knew if she wanted to study more, she had to leave Russia. And the only way she could leave Russia as a woman was with a male companion of some sort. So either her father, well, that wasn't going to happen. A brother, she didn't have one. So the other alternative was a husband. And at this period in Russia, there were young men who were prepared to marry women in order to escort them out of Russia so they could study elsewhere, and with no strings attached, which is kind of quite remarkable, I think. So she marries, and so ends up going to Heidelberg, and then moves on to Berlin to study with Weierstrass, where she gets her a PhD. I mean, of course, she's not allowed to attend the lectures in Berlin. Weierstrass is really impressed with her, and he sends her work to Göttingen, where she's awarded a PhD in absentia. So she doesn't go through the kind of viva kind of process and things. So she's the first woman in modern times to have a PhD, but it's slightly different to the kind of PhD that comes a little bit later. She wins a prize of the Paris Academy, and she is championed by a Swedish mathematician called Gösta Mittag-Leffler. And Mittag-Leffler gets her a position in Stockholm, and not without a lot of opposition. And there's a letter from her to Mittag-Leffler, where she writes in 1884, she says, "I've received from your sister," Mittag-Leffler's sister, with whom she was very friendly, and who wrote plays and things, so that was where the kind of literary thing comes in. She says, "I've received from your sister an article by Strindberg in which he proves as decidedly as 2 and 2 make 4 what a monstrosity is a woman who is a professor of mathematics." And I think full marks to Mittag-Leffler actually for kind of absolutely championing her and actually sticking to his guns and helping, making sure that she had a position. There's another quote that I like to mention here. This is James Joseph Sylvester was a professor of mathematics in Oxford. He taught in America and he was quite a character. But one of the leading pure mathematicians in Britain. And he wrote, it was very much the accepted thing that you did in those days. When you wrote to people, you would exchange photographs. And so Kovalevskaya sent her photograph to Sylvester, and when he received it, he wrote back to her and he said that his assistant had said, "Why, this is the first handsome mathematical lady I have ever seen." So now there's kind of two things here. One is, of course, his assistant might never have seen a mathematical lady, so that's one thing. But also, I think rather more is the fact that it's the first handsome mathematical lady. So it's as if these two things, you know, really don't go together. And we'll see a bit more of that. And Kovalevskaya actually comes to London at one point, and she goes to George Eliot's salon. George Eliot, the well-known novelist, I'm sure most of you will have read some of her novels, and in fact, if you read them, you'll see there is some mathematics in them. And she actually studied maths and was a supporter of maths, and she invited Kovalevskaya to her salon. And at the same time, she had the philosopher Herbert Spencer was at the salon. And and this is a quote from Kovalevskaya herself. She says, George Eliot once turned to Spencer and said, "I'm so glad you have come today." She said, "I could introduce you to the living refutation of your theory, a woman mathematician. Allow me to present my friend." And then she turns to Kovalevskaya and says to her, "Only I have to warn you that he denies the very existence of a woman mathematician. Try to make him change his mind." And I mean, this is really quite shocking to us today, of course, but remember that at this time, a lot of men believed that actually if women studied mathematics and science, that it sapped their energy, that it wasn't possible, it would actually sap their energy and it would interfere with their ability, for example, to have children. And so the two things they just weren't compatible. And so it was really not possible to be a woman and have children and have a kind of, you know, family life and be a mathematician. And this is really captured, I think, by this quote from Kovalevskaya. So if we look at staying in England, we go to Cambridge in the 19th century. The first two women's colleges, Girton and Newnham, were founded in the 1870s. They don't become part of the university till quite a bit later. I think you can see from this Punch cartoon what's kind of thought about women doing mathematics. Girl graduate, single figure. And then this quote from George Allen in the Fortnightly Review: "Out of every 100 women, roughly speaking, 96 have husbands provided for them by nature, and only 4 need go into a nunnery or take to teaching the higher mathematics." So again, you know, we have this, it's not possible to do, you know, to have your husband provided by nature and do the mathematics. But then strange things start happening. Women are, so Girton and Newnham have been founded, there are women studying there. They are not allowed by right to sit the exams in Cambridge, but they can if they're given permission. And in 1880, Charlotte Scott was given permission to take the maths tripos. And there had been some women who had taken it before, but they hadn't been especially successful. But Charlotte Scott was successful. She was equal to the 8th Wrangler. And the Wranglers were the first class, and if you were senior Wrangler, you were the top of the tree. And if you were senior Wrangler, you were made for life, basically. You could have whatever career you wanted. It was such an important exam. It was the most prestigious exam in the country. The results were published nationally. They were published in local papers. The senior Wrangler, when they went home, they were feted and admired, and so on. So this was a seriously big deal. And particularly when you look at the people who were at the top in her year, Joseph Larmor was a senior Wrangler. He becomes Lucasian professor. That's the professorship that Newton had, Stephen Hawking, and so on. And J.J. Thomson was the second Wrangler. Well, he just wins a Nobel Prize. I mean, you know, these are seriously smart people. And Charlotte Scott came in. I mean, it was remarkable. And there was 102 men sat the examination. There were a few other women as well. And so this really made the news. And this is sort of typical of the sorts of things from the more popular press. Miss Scott has answered papers set for the mathematical tripos in a manner which would have brought her high on the list of Wranglers, an achievement of no common kind. We hope that the ability which the new system brings out and fosters in women will not be of a kind to give to those who possess it a character for deficiency in feminine gentleness. We do not believe that it will be so, but even in the rare cases where it is so, the world should remember that there have always been women of the masculine type, only that they have hitherto lacked the means of proving what they could do, though possessing amply the means of proving what they could not be. So again, maybe I seem to be labouring this point, but So one of the things that does happen, positive things that happens, is that after her success, they do agree that women can take the tripos by right. They don't have to sort of get permission. They can't get degrees, of course. Oh no, that would be definitely a step too far, because if you have a degree, then that gives you voting rights within university, and that's power. So that's certainly not part of the deal at all. But there are a number of men who are supportive of women and who go to Girton and go to Newnham and give lectures there. So there's a little bit of progress is made. Then what happens in 1890, 10 years later, Philippa Fawcett does so well in the tripos that she is actually above the senior wrangler. Her marks, and they are serious. I mean, she doesn't just get one mark, she's several, I think 200 or 300 marks above him. And so it says the list of the Cambridge mathematical tripos was published this morning. The sensation of it is the extraordinary triumph for Miss Philippa Fawcett, whose place was adjudged above the senior rank. I mean, this was such big news. It was in the New York Times. It was internationally spread. But just look at this list, and we can see, this is the list of the wranglers. She is above the senior wrangler, but of course she's still below. So, I mean, even says on the thing, it even actually says there, above the senior wrangler, but there's still, the list is below. They are not integrated, because it's kind of a concession to them that we're letting them take the exam and we're actually publishing their results, but we're certainly not going to integrate them with the men. And it's not until 1947 that Cambridge actually opens its degrees to women. Which again is incredibly late. And Oxford actually, 1920, and the Cambridge, I mean, the movement had been pushing and pushing and pushing. And of course, the First World War, as we know, made a big difference for women in many ways and so on. And so Oxford give in 1920. So then at Cambridge, they think, well, okay, now this is our chance too. And the Cambridge, if you want a degree, go to Oxford. Simple. So it wasn't until after the Second World War. So various other sort of aspects to being a woman mathematician at this time. Grace Chisholm Young, she didn't do as well in the tripos as Charlotte Scott or Philippa Fawcett, but she was clearly a talented mathematician. And she ends up, having done the tripos, I think she comes 20-something or whatever, she goes to Germany and she studies with Felix Klein. And Klein is very supportive of women, and she gets a PhD, and she's actually the first woman to get a PhD in the kind of sense we would understand a PhD now. In Germany, in fact, as well as, of course, in Britain. In fact, the PhD doesn't come to Britain until after the First World War. But she ends up marrying William Henry Young, and he was her tutor in Cambridge. And they work together. But this is a letter from him in 1902, and he says, "The fact is that our papers ought to be published under our joint names, but if this was done, neither of us get the benefit of it. No, mine the laurels now and the knowledge, yours the knowledge only. Everything under my name now, and later when the loaves and fishes are no more procurable in that way, everything or much under your name." So he's saying, look, we're both doing the work, but I'm going to get the credit. Because actually, if your name's attached to it, then no one's going to read it. Well, I'm not so sure he was right in that, but it also kind of belies an attitude. And there's work being done now, and there's a paper that's been published about the effect of gender in publication patterns in mathematics. And I mean, it's an important and very serious issue, but it's interesting to see it so kind of rawly stated in this letter. So I want to just flip to Germany and also flip back in time. So this is where we're going back to the 18th century. But this is also to show how really deep-rooted some of these prejudices against women doing maths and science are. So this is Immanuel Kant. A woman who has a head full of Greek, who carries on fundamental controversies about mechanics, like the Marquis de Châtelet, might as well even have a beard. A woman, therefore, will learn no geometry. The principle of sufficient reading or the monads, she will know only so much as is needed to perceive the salt in a satyr. The fair can leave Descartes in his vortices to whirl forever without troubling themselves about them. So basically, what Kant is saying here is women aren't going to do this stuff, it's going to be men. You know, it's so deeply kind of entrenched. And then we go to Felix Klein, who I mentioned just now in the context of Grace Chisholm, and he's really pushing for women's education. And in fact, the reason that Kovalevskaya was able to get her PhD through Göttingen was because they hadn't thought in Göttingen to actually write in the rules that it wasn't possible, and there was the sort of equivalent of the vice chancellor in Göttingen at the time was well disposed towards it, but it was by no means a done deal. And the thing that Klein finds is that he has foreigners in his class, but he doesn't have any German women. And he says the nature of the situation is that for the time being, these women have been exclusively foreigners: 2 Americans, an English woman, Grace Chisholm, and 3 Russians. No one would wish to assert, however, that these foreign nations possess some inherent and specific talent that evades us, and thus that with suitable preparation our German women should not be able to accomplish the same thing. So there's sort of, there's something kind of strange going on in the sense that, foreign women, they will kind of tolerate having tolerant women attending the classes, but not German women. And this is just kind of more of the same a bit. It's about American women going to Germany, because a lot of this was a period when American mathematics is really in its infancy. So a lot of American men go to the continent to learn their mathematics and then go back to America, and particularly they go to Germany. Charlotte Scott couldn't make a career as a mathematician in Britain. She actually gets a job as the kind of founding professor of mathematics at Bryn Mawr, the women's college. So she's really promoting. She's a big force for kind of promoting American women to study higher mathematics. So, and she's sending students to Klein as well. And we even see, Renata Tobis has been doing a lot of good work on this, about looking at what was really going on in Germany. And we even see that Hilbert was teaching the women as well as in part of Klein's course. So, so there's been quite a lot of work is now being done on how women, the kind of women who were going through the German universities, and where they came from and where they went to and what they were being taught and so on. And in fact, Klein helps to get women published in Mathematische Annalen. So we see Mary Winston, Charlotte Scott, Vera Lebedeva, but then Emmy Noether, a name that's probably familiar to many of you, probably the most talented woman mathematician of the first half of the 20th century, and she publishes a number of articles in Mathematische Annalen. Notice that in the title of the journal, it implies that it's basically a journal for men. So to say a little bit about Emmy Noether. And if you're interested in this story, it's been written up, and the whole details of it are in the newsletter of the London Mathematical Society, which is freely available on the web. But Emmy Noether, her father was a mathematician. She showed her talent and she was appreciated. I mean, Hilbert and other mathematicians in Göttingen really supported her. They couldn't get money for her, so she basically worked literally practically with pocket money. And then in 1928, there's a possibility of a professorship at Kiel, and due to the death of Ernst Steinitz. And then there's a correspondence between Frankel, who's at Kiel, and Helmut Hasse, who's at Halle, and they discuss the possible successors. And Emmy Noether's name comes up. And Frankel says, well, as far as Noether's concerned, there's no doubt that as a man she would have received a call a long time ago. And Hasse says, I'm astonished that you even seriously consider this possibility. Although I regard her highly in scientific matters, I deem her totally unfit to fill a regular teaching position, even less so in a small university like Kiel. I'm of the opinion that one should not make the experiment to appoint a woman as a full professor at such a place as Keele. The experiment should be tried first on a bigger scale where an unsuccessful outcome would not do so much harm. So the kind of implication is, well, we're expecting it not to work to have a woman professor. With someone of Emmy Noether's talents, which were by this time really well recognised and known, again, it's really quite shocking. How am I doing? Flipping over to the States, kind of little quote here at the beginning: all that a woman needs to know is how to read the New Testament and spin and weave clothing for her family, was a sort of what was considered in 1837. But what we do see is that actually women in the States start getting doctorates and becoming quite well educated within America itself during the 1880s. Note that in American men of science, Charlotte Scott, Anna Johnson, Pell Wheeler, and Olive Hazlitt appear. We can see that what the real focus for women is Bryn Mawr, where we have Charlotte Scott, as I said, who became the founding professor there. And actually, she really does make a career she publishes research articles. She becomes involved in the American Mathematical Society. She's an editor in the American Journal of Mathematics. Olive Hazlitt and Anna Johnson Pell Wheeler also make important contributions. Emmy Noether has a temporary position there. From 1933 to 1935, she's expelled from Germany with the rise of the Nazis because she's Jewish, and so she gets only a temporary position at Bryn Mawr. She's actually trying to get a permanent position at Princeton when she has an operation, and she dies unexpectedly young. And if we look at American women PhD students, we can see that actually, as well as at Bryn Mawr, there are various other institutions like Chicago, Cornell, that have a number of women, and actually quite a lot of women. And there's been quite a lot of work done on American women in mathematics. And thank you. And the thing that we can see that is quite interesting, actually, is that we see it rising from the 1880s right up, really, until the beginning of the Second World War. And then it dips before it goes up again. And that is perhaps not what one would expect. One wouldn't perhaps expect to see it quite as high as it is before the Second World War, but also one wouldn't expect to see it kind of decline quite as much. And I think this is because after the war, of course, there's much more kind of competition for positions and things, and there's economic situations. So there's interesting research. I just want you to show that, to see that actually the sorts of numbers you get aren't always what you expect when you start digging into the history here. I just wanted to draw attention also to mathematical societies. And we see, like the LMS, I've just put in the first women members here. Charlotte Scott's name keeps popping up. But the LMS was very actually receptive to having women members. It's quite a different thing, having women on the council and as president. So the first woman president was Mary Cartwright in 1961. And we've had Frances Kerwin and currently Caroline Series. And we see sort of similar things in the SMF and in the AMS. And also the International Mathematical Union. Ingrid Daubechies is the first female president of the International Mathematical Union. So again, there seems to be, as far as membership's concerned, it's one thing, but once the idea of having women having anything to do with organising societies, being involved and having positions within them, a very different thing. And really the movement for kind of promoting women in maths really got a big kind of kickstart in 1971 when the Association of Women in Mathematics was formed. And we see after that there's a number of organisations to support women in maths in various ways, whether they're sort of national organisations or more general, like the European Women in Maths organisation, or the LMS has its Women in Maths committee. So that we see as the 20th century plays out, more and more of these organisations are coming in. But I want to draw one or two little examples even from the 1990s. So this was the first European Congress of Mathematics, roundtable on women and mathematics. And Eva Bauer-Flückiger drew attention to this issue. So of course we're pre-internet days, and at this time if you wrote a mathematics paper or wrote a paper in anything, you would be sent a bunch of off-prints, and then you'd send them around to all your chums so that they knew that what exciting work you've been doing. And she said, well, many mathematical departments have printed postcards to be used for reprint requests. They contain a text that runs about as follows. Dear Sir, please send me a reprint of your article, blah, blah, blah. Thanks in advance, sincerely. A card that I received recently actually had this in 3 languages, namely, Lieber Herr Professor, Monsieur le Professor, Dear Sir. So, even at this time, the idea that you might actually be writing to a woman and asking her for a paper was not considered. And actually, the situation in Germany was considered to be really particularly bad at this time. Christine Bessenron wrote that the German situation compared with other European countries is quite deplorable. Approximately 1/3 of the students in mathematics are female, which appears not unreasonable. But only 9% of dissertations and 7% of habilitations are written by women, and only 2% of professors in mathematics are female. Investigating the status quo and compiling a list of obstacles that women in mathematics have to face in Germany was a very discouraging task. Considering all these difficulties, it's surprising that there are women mathematicians at all in our country. So this is 1992. It's not, we're just under 30 years ago. A couple of charts were gathered, statistics were gathered for percentage of women mathematicians in 93 and 2005. So the sort of turquoise blue is the kind of positive, that's the kind of greater than 30%, and then the pink is less than 10%. So we can see things have moved on a bit from 1993, where particularly in Scandinavia things have moved on from being less than 10% to just over 10%, and in Britain likewise. And then if we look at professors, of course the numbers are a lot worse, but that's perhaps not so surprising given there's a sort of time lag, but they haven't really improved. I mean, they do improve over that period, but perhaps not as much as we would like to have seen them improve. And it's sort of interesting seeing in Southern Europe that the situation tends to be rather better than in Northern Europe. And then from the beginning of this century, there have been a lot of new organisations for women mathematicians, particularly national organisations, and including things like African Women in Mathematics, lots of different ones. And so this is a really important move forward. And you can see all these on the IMU website. There's a list of all of these. But this is just to kind of give you a sense of how things really have, improved, and people are really kind of getting up and running with the idea that we really need to support women mathematicians. The Committee for Women in Mathematics, which was founded only in 2015, is kind of a focal point for all of these organisations. I want to include this quote from Ingrid Fischies. This was from her kind of when she was just finishing from being president of the IMU, and she was a kind of question and answer thing. And so she was asked, she said, "There's a common assumption that women are less good than men at mathematics. What could be the reason for this, assuming it is true?" So she says, "I disagree with this view completely. There is a highly variable percentage of women in academia and in departments of mathematics across Europe. Differences are so enormous that it becomes obvious that it has something to do with cultural habits, which differ from one nation to another, and not with intelligence. I have a very cynical colleague who says that the number of women mathematicians who are in academia is inversely proportional to some average of the amount of money and prestige that this job can grant. If there is little money and no prestige, there you'll find more women. I agree. These aspects seem to play a much larger role than being smart. I think it's kind of a really kind of interesting comment, and from somebody whose opinions are really worth listening to. Really, so I think this is something that we really need to bear in mind. So just looking at women mathematicians in the UK, so this was the state of play in 2011. 6% professors, senior lecturers, 21%, researchers, 21%. And this was the situation in 2016. It had gone up a bit, but professors 9%, not much actually for lecturers and researchers. And I know data is being collected. Eugenia might say something about that. But I know the situation, I think, for women professors now is more like 11%, something like that. And I don't know the numbers for the others. But so we're kind of edging there, but the numbers are still not good. And particularly, I think it's very disappointing to see them not improving as fast as we would like. Not to steal Eugenia's thunder, but this is just to say, there is a lot being done in the UK to get more women into maths. Athena Swan, which I'm sure you're all know about. It's been a really important motivating factor, and maths departments who've got Athena Swan awards have gone up from 3 to 41 in 5 years. I'm particularly proud of the fact that I'm at the Open University, where Gwyneth Stallard, who had the position of, she was chair of the Women in Maths Committee prior to Eugenie, was awarded an OBE for the amount of work she did for supporting women in mathematics, and that gives you an idea of the kind of amount of work that Eugenie is having to do to kind of carry on with this important work. But I want to finish with a couple of positives. Mariam Mirzakhani winning the Fields Medal in 2014, the first woman to win a Fields Medal. For those of you who are not aware, the Fields Medal is the sort of premier award for mathematics. 4 of them get awarded at every international congress, which is held every 4 years. When it was first laid down, the first ones were awarded in 1936. It wasn't actually explicitly stated that they should be awarded to mathematicians under 40, but because of the circumstances at that particular time, and because of who they wanted to award the medals to, that is what kind of happened, and that has now been sort of written into the rules, as it were. And there was a lot of concern that a woman had never won one until 2014. Very tragically, Mariam had cancer even at that stage, and she sadly died in 2017. But this was a really big moment. And actually, a little kind of aside, in the medal ceremony, when they handed out the medals, and you get, not that I've been handed out a Fields Medal, but when you get a Fields Medal, it has your name on it, and they get handed them out. And when they handed them out, they got them wrong. Mirzakhani didn't get one for her, she got one of the men's, and one of the men got, and they had to kind of swap them around. I mean, it's kind of a little detail, but you would have thought they might have got that right. And then, of course, this year, really great news that Karen Uhlenbeck won the Arbel Prize. And I think the Arbel Prize, in some sense, I think the Norwegians sort of came up with the Arbel Prize because there isn't a Nobel Prize in maths. People talk about the Fields Medals as being like the Nobel Prize in maths, but it is different because of the age thing. And so the Arbel Prize also, there's a lot more money attached to the Arbel Prize than there is to the Fields Medals. And it tends to be for, you get the Arbel Prize towards the end of your career. And so this was the first time it was awarded to a woman. So that was a great cause for celebration. And that's, I know that's my last slide, so I think it's nice to be able to end on a really upbeat note. So, thank you.